Hello and welcome to another session of solving problems with Elixir. We are going to practice again our function design recipe steps using a problem described here, which is determining the next traffic light state. So we know traffic light has three colors, and given a current color, we could always know what the next color is, and the function that we are going to design is that given the current color, what should be the next color. So in order to make all of this implementation simple, let's represent this traffic light data using simple strings. So in that case, if we just look at the first example, this will look like that the given state is red, and that should produce string called green. So with this as our problem statement, I would once again encourage you to pause the video, go back to your editor and do these steps on your own, and then you can come back and see my solution and learn from that as well. So with that said, let me go back to the editor and start our function design. So step one, as always, is going to be the spec, which is the signature of the function. That asks us to think about the name of the function. Let's call it next state, and this is going to take a value of type string, and it's going to produce a value of type string. Step two is the purpose, so we're going to say produce the next state of traffic light given the current state. Step three is the stub, so we're gonna write the name of the function, and this asks us to think about the name of the parameters. I think let's name it as current state, start our do block, and the value has to be of the type string. That's what is given in the signature. So let's produce a simplest form of the string, which is empty string. Moving on to step 4, we are going to write test cases. So for example, red should produce green. Make an assertion that our next state function, when given red, should produce green. Let's just copy this few more times, and green should produce yellow. So green should produce yellow, and yellow should produce red. All right. So these are our 3 test cases. And before we move on to the implementation, let's run our mix test to make sure that our stub and the tests are syntactically well formed. So we run the tests. It says 3 tests and 3 failures, and those are once again expected because we have not implemented our function yet. Now at this point, let's look at what our implementation should look like. So we are given a current state, and that state can be one of the three strings. It could be red or green or yellow, and for each one it will produce the next state. So one way you could think of to implement this is the conditional implementation, where you can compare using an if-else clause. So you would say if current state equals red, then output this, else if current state is, but that becomes quite clunky, especially when you have more than two choices to make. So if-else clause is good if you have a binary choice, but in our case we have three different choices. So Elixir provides us with a clause which is called case clause, and in the case clause we can compare conditions and which has multiple branches. So more than two branches are more clearly handled with the case clause. But let's hold on to that thought for a moment, because Elixir also provides us a third way which is even more clearer, and that is through a concept that is used very common in functional languages, is called pattern matching. And we have seen before one use case of pattern matching where we said multiple functions with same names can exist, and you could think of those as different clauses of the same function. So one test we had already run was that, let's say we had a function that takes one argument, and then the same name function f that takes two arguments, right? And this is our implementation. And if we call this function f with an argument 1, we know that this clause will be called because there is only one argument. But if I call the same function x with f with two arguments, now we know that the match is with this clause, so this clause will be called. So this is one way Elixir does this pattern matching for us. There are many other ways, and we are going to look at one additional way here, and that is using the exact values. What I mean by that is, if I have two clauses, the first clause says, for example, a string A equals, and then the second clause says string B equals, and this is my implementation. And if I call the function f with string B, it is going to run this clause. And if I call the function f with string A, it is going to run this clause, because it is not only able to match the number of arguments, in this case which we already have only one argument for both clauses, but pattern matching is also able to match the exact values as well. And this will become quite handy when we look at more complex data structures, if you will. This becomes quite more powerful feature. So let's go ahead and use this functionality of Elixir to design our function. So that also relieves us of not having to worry about the parameter name, because we can match the exact values. So exact value is red, and this is going to produce green. One more thing we could do here to make the implementation simpler is that since it is one single simple expression that is that forms the body of the function, we can do it all in one line by using comma after the arguments and do colon and take the end from there and put the expression in front of do. So we have two more additional clauses to write. So let's copy here and say if the state is green, the next state is going to be yellow. And then if the state is yellow, next state is going to be red. So here is our function implementation, which uses three different clauses of the same function using pattern matching of values. So this function will be called only when I call this function with the argument value of red, and so on and so forth. So with that, let's run our tests again using mixed test, and all three tests pass. So that's it for this exercise. We have practiced our designing functions recipe, but we have also learned how Elixir's simple pattern matching idea can make the implementation much more cleaner in this case.